Okay, 5.1 polynomial functions today. This is one of those book sections, like I taught you or told you yesterday, that should really be 2 sections, not 1. But in our double-paced pandemic lifestyle, we're going to do the whole damn thing. So, polynomial. Polynomial is a word with 2 meanings, of course, because we like to make math hard for you. What I have on the board are the book definitions. Now, I always like taking the book definition and redefining them into more kind of sensible, high school student-friendly language. So like when I think about these definitions, I'm always trying to come up with a different way that's easier for me to remember and in turn for you guys to remember as well. So we're going to start reading these and then we'll kind of rewrite to make them easier to understand. So the degree of a monomial in one variable is the exponent of the variable. Okay, so with this one, I don't really need to rewrite it, but what I like to do is just give you examples of a monomial so you know what it means. So monomial is one term, right? So that's probably a good thing to write down. It's only one term. Because you'll know exactly, you should know already what a term is, but by the end of the lesson for sure, you'll know what a term is. An example of a one-term monomial would be like 2x squared, right? So you can multiply things with the variable, still a monomial. As soon as you add, so if I did x squared plus 2, that's then a binomial. So 2 terms are separated, terms in general separated by plus or minus. So that's 2x squared is an example of a monomial. I could say like 2x to the 10th, y to the 3rd, z to the 4th. Still a monomial. So I could multiply like 28 things. If I don't have a plus or a minus, it's still a monomial, a single term. Okay? So that's what a monomial means. Oh, that was the degree of the monomial. So whatever. You can use that for both of those. So polynomial is like any of these things. Once we get 2 slides later, we're going to have this big chart of things to talk about. And you'll understand the difference between polynomial, because polynomial has the 2 meanings. So it's an overarching term which talks about anything. Could be 2x squared, polynomial. Could be 2x squared plus 4x plus 8, still polynomial. 2, polynomial. 0, polynomial. Okay? If we're talking about the number of terms, polynomial means 4 or more terms. Okay, we'll define that in greater detail 2 slides from now. So don't write the chart down at top, and if you want to wait and not write the definition and wait for my redefinition, you can do that. If you like the book definition as well, eventually you'll have a math class in college where, and I'm thinking of a couple different college professors I had, like I was taking calculus 2. I had this college professor who had such a thick accent, I couldn't understand what they were saying. And the issue was, Calc 2 is really freaking hard, right? And if I couldn't understand the words coming out of the professor's mouth, I wasn't going to pass Calc 2. So I dropped that class and I found a different professor. So what will happen is sometimes you won't be able to drop the class, find a different professor. You'll have to stay in the class. You'll have to read these kind of definitions and try to understand them. Thankfully for you guys, you got things like Khan Academy, which is like crystal clear explanations of things through every math class you could possibly take. So you can use that if you get stuck. It's a great resource. I encourage you to do it. The other good thing to do in college, I think I've said before, is when you're doing your math homework in college, do it in a math tutor center. You'll literally have like a little flag. You stand up the flag, a little math nerd comes running over and says, are you taking Calc 1 or 2? And you say Calc 1, and they're like, okay, I'll help you in this way. And then you find the right math nerd for you who can explain it to you so you get it. But that's how you can get through some of those harder math classes in college that many of you guys will face. So standard form. The book definition arranges the term by degree in descending numerical order. That's relatively easy to understand. I like writing it and saying descending order by X. My little cursor thing just lost its mind. Descending order by X. Right, so if it's just highest exponent first, next highest, and so on. Not that hard, right? So this next thing, sometimes when I copy text onto these slides, it'll do weird things with it. Like this of turning point should be a step above there, but whatever, still good enough. The degree of a polynomial function affects the shape of its graph and determines the maximum number of turning points. So again, that's like, what? I don't get it. But what I say is, let's say we have positive 2x cubed. I know because I've taught this for many years, the general shape of that graph is going to be like that. So how many times does that thing change directions? Twice, right? So the turning points are one less than the highest degree. So highest degree is 3. Subtract 1, 2 turning points. So if I had x to the 99, we'd have 98 turning points, right? Normally we'll do like x squared, 1 turning point, x cubed, 2 turning points, x to the 4th, 3 turning points. So it'll be kind of easy. So just so you know what an x to the 4th one looks like, positive x to the 4th kind of looks like a w. And it depends what else is going on with the x to the 4th, what it looks like. But that changes directions 3 times. Highest degree is 4, so I'll have 3 turning points. Okay? So no big deal. You guys can get that. End behavior. So looking at the same 2 I did here, when I'm thinking about end behavior, so we can look at 2x cubed. We'll write the 2x to the 4th again as well. So for the end behavior, my little trick for that one, all I think for end behavior is arrows on the end. So if I throw some arrows on the end here, what's the end behavior of this 2x cubed? First it goes up or down? Down, then it goes up. So end behavior here would be down, up. Right? So if I have a positive a, the w, it looks like a w as opposed to an m. Just like if I have a positive x squared, it's right side up, negative x squared upside down. So positive, even exponent, end behavior is what? Up or down? Not up, up. Not a hard question, right? All of you high school kids, you know you get into the habit of overthinking things, making it way harder than it is, right? My job as a good math teacher is try to make it easy for you. You make it hard. I try to make it easy. The content can be difficult, but I try to explain it in such a way that it's easy to understand. Okay, so we got this big massive chart. Just so you get a sense of how much space you need in your notebook, we're going to go from 0 to 5 on this chart. Okay, so you'll need 6 spaces. So if you want to go to a fresh page or you got a half page left, you should be good. So just write down the title, make the columns, and then we'll start filling it in. Once you're done with that, I'll give you a little bit of time to do that. Hopefully this will be the weirdest year of your life. Right? Pandemic, 12 months, like what the heck? We shut down last year, Friday the 13th. I know that date because that's when my Pi Day was supposed to be. And I got a couple emails from a teacher kid that was in my class where the kid was like, woohoo, I'm making a pie, like he was showing it all proudly. And then it got announced school shut down. And the same kid holding the pie, like head down, just sad. Like, yeah, that sucks, man. Nobody enjoyed that. Okay, so people are almost done. Couple people still writing. Give me a little virtual hand raise if you're done writing the little columns at home, just so I know. So I can assume like half of you aren't done writing yet, or are you just not hitting the button? Okay. Alright, so we're going to start with 0. Name using the degree is constant. So a degree of 0 is called a constant. So constant generally is just a number, right? No variable, just a number. So you might look at that and go, well, how the heck is that a degree of 0? Here's how it's a degree of 0. Because there's implied x to the 0 there. Because x to the 0 power, or anything to the 0 power, is 1. Right? So 2x to the 0 power is the same thing as saying 2 times 1, which is 2 all over again. So that's how it's a degree of 0. You just have to have that implied 0 in your head, which I know is weird, but... So if we have just this 2 right here, how many terms do we have? Just 1. And one term, like we learned 2 slides ago, is called a monomial. Next, we'll do a degree of 1. 1, when you're thinking about the name for a first degree, you're thinking about what the graph looks like, because what you guys are going to have to do, right, we're learning this topic, we'll spend another day on it tomorrow. You're going to have spring break, then we finish the rest of the chapter. The rest of the chapter is probably 6 or 7 more sections. That'll take us another 2 weeks after spring break. So you're not going to have a test on this, right, because I'm testing you on each chapter this semester. Your test on Chapter 5 is probably going to be like 3 weeks after spring break. You have to remember this stuff, okay? You can't use notes anymore this semester. So I was hemming and hawing whether I would give you a quiz over this section, over 2 sections to the last one of this. And I'm not going to give you a quiz, but what I am going to force you to do is to make some flashcards. Okay? You're going to make some flashcards because eventually, to pass math classes in college, you'll have to make flashcards. You will have no choice. You won't be able to pass unless you do, because you have to remember so much stuff. And remember, in college, a lot of times in math class, they'll give you like a midterm and a final. That's your grade. You're sick on the day of the midterm? Too bad. You go take the midterm. Like I took a final in business school. I went to Leeds Business School at CU with like 102 fever. And the professor's like, that's nice, take the final. And I was like on cold medication, my head's all foggy, and I did not do well, but they're like, too bad, deal with it. So the little nice Mr. Nice Guy kind of thing kind of ends in college. You might get a couple of nice professors, but just know you got to prepare yourself for that. So I'm going to help you by doing that. So your quiz grade tomorrow, we're going to spend another day on this topic, is going to be creating some flashcards to remember all of this content. I'm going to give you, or you can have like a little binder clip or a rubber band. I've got some rubber bands, they're kind of old, hopefully they won't break on you. But what I would do is generate a pile of flashcards for each chapter in second semester. Because what makes second semester harder is we start teaching you entirely new content, right? Stuff you've never seen before, and that's what makes it harder. It's not like the material's that much harder, but it's a bunch of new stuff. So just because it's like that, that makes it harder. So if we graph a first degree, it makes a line, okay? An example of that would be like 2x. We'll just add another term, right? Terms are separated by plus or minus. So 2x plus 1, we start at 1 on the y-intercept, right? Go up 2, right 1. It's going to graph and look like a line. So this thing has two terms. A bicycle has two wheels. Instead of a monomial, it's called a binomial. Okay, second degree, we've been talking about this. The entire last chapter is a quadratic. Okay, we're going to just kind of continue on this theme here. So let's say we have 2x squared plus 1x minus 3. So now we're up to 3 terms. A tricycle has 3 wheels. It's called a trinomial. So what you're going to be doing on the next slide, we're going to be naming these by degree and number of terms. You'll be writing these things in standard form, right? Like what I just wrote in the middle here is in standard form. We go squared to the first power, no variable, technically x to the 0, right? That's in standard form. So you put it in standard form first. You combine like terms if you have to, and then you would name it by degree and number of terms. So the example I wrote right here would be called a quadratic. You always say this one first, and the number of terms named last. So this would be a quadratic trinomial. That's what you've been factoring in the last chapter, completing the square, quadratic formula, all that stuff. Third degree is called the cubic. I think of a cube with 3 dimensions. That's how I remember the term cubic. 2x cubed plus 1x squared minus 3x plus 1. So now we have 4 terms. Anytime you have 4 or more terms, it's called a polynomial. Poly means many. Polynomial. I'll slow down, make sure people are caught up here. So 4th degree, 4 quarters in a dollar, quartic. So we're done on the list on the far right. Monomial, binomial, trinomial, polynomial. There's no more after that, right? Poly means many, so 4 or more. So I'm just going to make it random as far as number of terms. So just say 2x to the 4th minus 1. So we just have 2 terms then. 2 terms, binomial. So if we name this in the middle by degree and number of terms, it would be a quartic binomial. We did virtually this exact same chart if you had me freshman year, literally the exact same thing. So if you don't remember that at all, that's a good moment for reflection, don't you think? Right? Just be like, wow, I have no idea, I've never seen that before. Think about that. 5th degree. I don't have a little trick for 5th, sorry. Quintic is the word. So a quintic, I'll just make it a monomial, like 2x to the 5th, one term, monomial. So this kind of question on your test a month from now is perfect for multiple choice. It makes it really easy to make a multiple choice one for this. So yeah, you'll see a multiple choice for this. All right. Want to make sure everybody's done. Give me the little virtual hand raise so I know you're done before I move on. I don't want to go too fast for people. Thank you. All right, you're good. You can take them all down. That gave me enough information. Anyone else need more time in person? All right. So write down the A and the B one. We have to write these in standard form. So remember, standard form is decreasing order by x. So highest x, next highest, and so on. Like I say decreasing order by x, that might confuse you. You might want to write the definition as make sure I have the highest x exponent first. Like if that makes more sense to you, write the definition that way. That's fine. And then, so once we write it in standard form, you look to see if you have any like terms to combine. You have to combine the like terms before you name it by degree and number of terms. So no like terms on A. How do you know if it's a like term? You've got the same exponent for it to be a like term, right? So if I look at the B one, I can tell I have like terms because I've got two x squared terms. So I'm going to have to combine negative x squared and positive 10x squared, right, when I do that problem. Not the hardest thing in the world, that's for sure. So we have 9x squared plus 3x plus 5. And over here we have x to the 4th plus 4x squared plus 4x minus 12. Sometimes if they give you huge long string, not that that's a huge long string, but I'll cross them off as I go, just so I make sure I don't miss one, because that's a terrible reason to get a test question wrong, just because you missed one of those terms. Just annoying. So now we've got them in standard form. Let's name them by degree and number of terms. So I want you to look at your chart, look for the highest degree, so the biggest exponent. That's what you're going to name it by degree, and then just count the number of terms. That's how you name it by number of terms. So what is this first one called? You can unmute at home and tell me as well.
Quadratic trinomial.
Beautiful. Quadratic. This is what, like I said before, we've been doing for the last chapter. So many of you should know that it's called the quadratic trinomial. How about the second one? Anyone in person got that one? Yeah.
Polynomial.
It's the birthday boy. Quartic
Polynomial.
polynomial. Perfect. Good job. See, you're smarter now. It's gonna fail. Come on, you can do it. It's at the worst possible time when it keeps dying too. He's blinking. I don't know what that means. No, there we go. Sketchy. Quartic polynomial. So try A and B on your own. Combine. We'll just talk about them. I'll scroll up a little bit so it's easier to see. So try those on your own. Standard form, remember, combine like terms if you have to. Bust a move on that. I'm going to charge my pen on the pauses. I don't know what's going on. So you only have like terms to combine on the B ones, so make sure you do combine those like terms on the B ones. So you should be done with the first one. I'm not going to write it on the board, I'm just going to tell you what it should be, although, does anyone want to tell me what it is? At home too, you could tell me, or in person. Don't be lame, somebody tell me. Rachel, I know you got it, what is it?
What's the answer?
Yes.
A quartic trinomial.
Quartic trinomial, perfect, good job. Second one, fifth degree, right? You should have it in standard form as negative 4x to the fifth plus 2x squared plus 13, right? So that would be a quintic trinomial. Okay, so they're both trinomials, cubic for the first, quintic for the second. And now we get to move on to the good stuff. So, give me just a rough sketch of the graph. Give me an XY coordinate plane. Give me a rough sketch of the graph. Write the equation down. Write down the end behavior, turning point, decrease, increase, decrease, etc. And just so you know, on this first column down here, there's an increase below this decrease. So it goes decrease, increase, decrease, increase. Right, and it will also alternate between increase, decrease, and we'll talk about how it all works once you guys are done writing that down. So give me a sketch of both. We're going to do 3 of these, because this is kind of the most challenging thing to understand here, because we're putting together a lot of information. End behavior you should be able to fill in on your own right now. Arrows on the end, right? Up, down, up, down, down. Which is it? What's that first one? Up, perfect. Second one? Yes. So we got up, here, arrows on the end, up, here, we got down, down. Down, down, arrows on the end. Turning points. One less than the highest degree. The first one is a quartic. One less, 3. So 3 turning points. Second one is just x squared. So it only has 1 turning point. To figure out these intervals, there's a whole lot of stuff going on to figure out these intervals. So I'm going to write some notes down here, the stuff you need to think about. So when you're dealing with the increase-decrease portion of the program, you want to think only about that. Well, first, let's say you wanted to know whether the function is increasing or decreasing. I want you to think about a roller coaster car. Okay? The other thing I want you to think about, so if that's like the first thing I want you to think about, second thing I want you to think about is we're only using x values when we think about increase, decrease. So only x values. I'll give you a sec to write that down. now what you guys can do is we're going to plug these into the graphing calculator. So you can take that first one, hit your y equals, start to plug that in. The way you get x to the 4th power, you hit the x right above the divide sign. There's a little caret, so you would hit x, the caret, and then 4 if you want 4th degree. You'll catch on your birthday. I see you get a little nervous, but I still have faith. I got faith in you. How old are you today? 17. Michael Blazer is 17 today. Very exciting. I'm trying to embarrass him as much as I can. So, it's not...
You did a great job.
I know.
Congratulations.
Michael, it's not the end of it either, just so you know.
Oh, I know.
We'll keep going. You're like, oh God. Okay. So, we're going to throw these into the graphing calculator. It's one of those I love to hate you kind of moments, right, Michael? So, we got, somebody tell me what that first one was?
4x to the 4th.
4x. I have to watch this thing because it does weird stuff. So, before, just stop right there. So, you'll notice the cursor's up here like in exponent land. So, if your calculator is like this, you got to hit the right arrow. Sometimes I have to hit the button twice. You got to hit the right arrow to get back on the 4x level out of the exponent level.
Plus 6x to the 3rd.
Third time's the charm. Fourth time? Fourth time is the charm. Okay?
Minus x.
Minus x. Thank you. Okay, so throw that in there. Make sure your plots are off. If your plots are on, they look like this. Right, plot 1 would be on for me. I go up there, hit enter. Now it's off. Click window next. Just to see if you're in a regular window. If you've got a jacked up window, you just hit zoom 6 to get back to this window. And then I'm going to click graph. Your graph should look like that. So let me know if you're having a problem so I can help you now before we get much further. You're all good. Alright. So I have to get, these things are called relative minimums and maximums. So I have 2 minimums, one right here, and I have 1 max in the middle. If I'm getting min to maxes with the graph that tightly together, I don't like that. So I'm going to zoom in. So literally hit zoom, number 2. That's zoom in. And then you can see my cursor right there, almost in the middle of the graph. I'm just going to move over a smidge. And then you have to hit enter so the calculator actually zooms in. And then it's much easier to get a min and max, right, because we're zoomed in like that. And if anyone has a problem doing that, let me know. Okay. So we're going to get that first minimum, right? Looks like a U right here. So we're going to get that min, second trace. The calculator directions are still on the top of the Schoology page, so if you struggle doing calculator stuff, as I saw, I still have, I don't know, maybe like 10% of you of the 90 Algebra 2 students I have, so I have about 9 of you who have no clue how to use a calculator. If you're in that boat, you've got to start asking me, because we keep going with the calculator. So if you're clueless, it's like a 20% reduction in your grade second semester, just because you won't be able to do some of the problems. So make sure you're asking me coming to access time if you need to, so you don't have that failure in your life. Nobody needs that. So second trace min, click enter. Then I arrow over to the left side of the U. Hit enter. Arrow over to the right side of the U, hit enter, it says guess, hit enter once more. So we're going to round to hundredths. You'll always get weird little decimals like this. Well, I say always, but most of the time you will. So we're going to round to tenths, let's say. So we get negative 1.1, negative 1.0. That's what our first minimum is. So negative 1.1, negative 1.0. So I'm just going to identify this up here on the graph, negative 1.1, comma, negative 1.0. So that's the relative minimum, right there, right? There are two minimums, that's why they add that word relative, because we don't know it's the only minimum, so they say relative minimum. Next thing we'll do is get this maximum right here. So the max in the middle, should probably use a different color. So that max, let's get that thing. So we're going to do second trace number 4 for that. Go up. That's good. Right side. So when I'm moving the cursor, I just can't move it over to the other side of that second hump. I got to be kind of in between. So we get negative 0.3 and 0.1 rounded. Okay? So again, we're going to be using these x values only, right? So when I'm writing the intervals, I'm going to use these two x values, and I'll make you give me the whole minimum, both x and y. You're going to get it anyways by doing it on your calculator. So it's not me being cruel or anything, it's just good to do. So second trace min again for the next little turning point. Second trace minimum. And you can see my cursor isn't like perfectly even on either side of the little minimum. It doesn't matter. Close enough. Calculator does the math for you, so you don't have to freak out. If I made you do that by hand, you would just want to kill me. No need. So we get 0.2 and negative 0.1. So this last one here. So close. Okay, so when we build out these intervals, we're again only using the x values. I'm going to erase this stuff here just because it gets in the way. Maybe I'm going to erase, there we go. So when we build these things out, here's how I want you to start it. X in the middle for all 4. Increase or decrease, increase, decrease, increase. You will always, every single time, have less than or equal to's on either side of the X. So you can just start out doing this. Okay, we're always, for me, going to start at negative infinity and end at positive infinity. Sometimes the book will give you a range of values, like they want you to consider x values from negative 10 to positive 10. I won't do that. When I test you on this, we'll always have negative infinity. So your infinity, like that, positive infinity, there, sideways 8. If you struggle doing that, I used to epically struggle. They're not beautiful, but they're passable. I start in the middle and start going down to the right, and for whatever reason, that helps my brain make the sideways 8 better. So then all I have to do is write my x values in order, right, left to right. So the first x value, you can see up here in that orange highlight, is negative 1.1. So that's the first one I do up here. That repeats right here. Okay, it always works that way. Starts at negative infinity, first x value repeats below. Then I look for my second x value. Second x value is at 0, negative 0.3. That's what I write next here. That repeats on the next line down. And then my last x value from the last min was 0.2. So I write 0.2 here, and it continues below, and we're done. So just build it out. Write all the x's, write my less than or equal to's on either side of the x. You start at negative infinity, you go to positive infinity. I know, Steve's outside. He's like, oh my God, what's going on? What's up, my man?
Do you have a blazer in here?
Which one? I got two.
Get Edward.
Eddie in the back.
Eddie.
How you guys doing?
Good.
Yeah.
Appreciate that. I like the math. Are you learning?
Thank you.
learning? Are you learning?
Oh, they're learning.
It's an amazing teacher right here.
Well, thank you, sir.
That's my guy back there too.
Yes.
He's a good athlete.
Yeah.
Good teacher right
You're
here.
going to be varsity next year,
Oh,
right?
there's no doubt.
No doubt. I love that. No doubt. All right. So that's it, right? Build it out, no big deal. The only thing I forgot to emphasize is that roller coaster car concept, to know when it's increasing or decreasing. I'm actually going to go down here further just so we can generically talk about it. So we just worked with the cortex, right? End behavior, arrows on the end behavior. Come on, don't do it to me. Take this freaks out. We just want to think up. If I'm thinking about increasing or decreasing, I want to envision a little roller coaster car. So that's the difference. Now it's decreasing right there. Right? So this part is decreasing. Right here it's increasing. Right? So you're on the little roller coaster car, you're going down the hill. Woo! Right? Going up the hill, a little click, 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 right? Crest over the hill. And then you're freaking out happy again. Decreasing there. So this part is increasing. This part is decreasing. And then this part right here is increasing. So that's what I mean with the roller coaster car concept. Because I'll give you this, I won't tell you whether it's increasing or decreasing. You're going to have to tell me. Right? Before I wrote it for you up there. Right? So if I just think of one that looks more like an M, right? It would increase first, then decrease, then increase, then decrease. Increase, decrease, increase, decrease. So that's all I mean by it, right? And you'll have to write that on your own a month from now when you take this test. I just want to emphasize that. 3 weeks from now, what are you going to take? April 13th? SAT, yeah. Spend a little time this spring break, couple hours, look at an SAT book, read some strategies about SAT. Like the day or two before, I'll talk strategy with SAT. I will tell you a hilariously humiliating story about myself taking the GRE. GRE is what you take to get into grad school. I just had like an incredibly embarrassing moment. And I, of course, you know me, I don't care, I will share that with you. So the reason I share that with you is because when you're taking SAT and you're freaking out, you're stressed, you're like sweating bullets, if you can think of me being that stupid and laugh, just that laughter, even if you chuckle to yourself, you'll do better in SAT just because of that, right? Because it'll relax you if you laugh in the middle of it. It's like your parents telling you to take a deep breath when you're a little kid. Right? And you're like, I want to murder you. But taking a deep breath, it actually works, people. Okay? So we're going to throw the second one in order to get that max. It's obviously easier because we only have one turning point. So negative x squared plus 2x. So click your y equals, clear out your old one. We have negative x squared. Why did we do that? Negative x squared plus 2x remember, we mess with our window, so click window. It's just a good habit to get into, so you're checking to see what your window is. You're like, oh yeah, I screwed it up with the last problem. So then you hit zoom 6 to get back to a regular window, and bam, there you got your graph. So that is what, a max or a min? Max, right? Looks like a mountain, mountain max. Question? Just hit zoom, top, middle, 6. And it'll look like this. Let's look. Because you're plotting on. There you go.
Is this the second equation? Oh, it's wait.
Yeah.
I'm not.
Yeah. Negative x squared plus 2x, yeah. So second, trace, maximum, left bound's in a great spot right there. Right bound, over the hump. Guess, hit enter once more. So look down here, you guys, right? Because a lot of times you'll screw it up. You forget to hit. It'll say guess, and you write that one down. You got to get to where it says max. Write that one down. So that rounds to 1. So it's just 1, 1, right? That vertex. So our vertex up here. And you could have gotten that from the graph itself. But don't assume. I didn't mean to write 1.1. We'll just turn that into a comma. 1, 1. Okay? So, writing that interval, right? We always start and end. Start at negative infinity, end at positive infinity. So we can just build that beginning part of it out. Less than or equal to x, less than or equal to, less than or equal to x, less than or equal to, always that middle is the same. It is always less than or equal to. We know we end at positive infinity. So right there, before you even write the rest of the intervals, you probably got 2.5 out of 4 points on a test. So don't freak out about it, it's all good. If we remember the x value was 1 up here. So all you got to do is 1, 1, done. No biggie. Okay? End behavior, down, down. 1 turning point because it goes from increasing to decreasing. Build in that less than or equal to x, negative infinity, positive infinity. I won't give you one like that on the test because it's too easy. I won't give you an x to the 4th. I've tried it before. Too many students bomb it. But I will give you the last one we're going to practice, which is a cubic. So you can anticipate right now, I'm telling you, a month from now we're going to do a cubic for this. And this is the last kind of main problem we're going to do. I'm going to show you a chart which you can choose to write down or not. I'll explain how to use it. The chart on the next slide does not work at all for my brain, but some of you guys like those charts. Everything's in its nice little orderly place. So if it works for you, fantastic. I'll tell you how to use it. So end behavior. What is it for this cubic? We're doing the second one. I didn't tell you that, my bad. If you already started, not that big deal. But negative x cubed plus 2x, so not this one, we're doing this one. So what's the end behavior? Up, down. How many turning points? 2. We can even start building out the decrease, increase, decrease thing, right? Because we know we start negative infinity, less than or equal to x, less than or equal to. and then positive infinity. Come on, work for me. That's hard when you don't know when it's going to write. And then all we got to do is get the minimum first and the maximum second. Use those x values. So negative x cubed plus 2x. Let's throw that in. So I already have negative x squared. So negative x cubed. And then it was plus 2x. So I'm good. I can just leave that. Right? You can remember we're already in a regular window, but you can also just double check to make sure and then graph it. Should look like that. If you want to zoom in so it's a little bit easier to get it, that's not a bad idea. Zoom 2, cursor's in a perfect spot, enter, makes it just much easier to do it, right? So you hit zoom 2, enter to make it do that. And then second trace min to get this minimum here. So we get negative 0.8 and negative 1.1 rounded to 10. Negative 0.8, negative 1.1. So sometimes this will happen. The maximum is just a positive version, same numbers. So we could go into great depth explaining why that happens, but we're not going to go there in a regular class. So we're going second trace, number 4. Right, so positive 0.8, positive 1.1 for that one. And then it's like we're almost done. You just write the x value on the top row, repeat it on the second row, second x value at the end of the second row, repeats on the third row. So negative 0.8 right here, negative 0.8 right here, positive 0.8, and positive 0.8. So you can expect to have one like that on your test. If you're a smart human, you get your different color and you write on test, dumbass, so you don't forget, right? Okay. Once I see people stop writing, then we'll go to the last, write the chart. I don't care if you write it down or not. Many people have been writing it down. It kind of helps you sort through things. Again, it doesn't work too well for me, but that's me, not you. Okay, so when they talk about this A positive N even thing, they're talking about this thing right up here. Right, so we've already talked about positive A, negative A in terms of quadratics. Right, if it's x squared, positive A right side up, negative A upside down. So this deals with any exponent. Okay, so we're going to focus first right here in this square when it's an up. Okay, so A is positive, and we're going to write a couple examples of positive A. So let's say we have 2 is a positive number. Even exponent, we'll just do 2x squared at first. I'm going to show you in the graphing calculator what that looks like. You already know kind of what it looks like. I'm going to go back to my standard window. You don't have to graph all these. I'm just going to show you a bunch real quick. Right, so 2x squared, M behavior, up, so on, question?
I didn't finish writing that chart down.
Okay?
Can you go back to some?
Yeah, I'm going to go back and forth. I'll be coming back to it frequently, so don't worry about it. So 2x squared looks like that. So again, positive 2, even exponent, we'll try 2x to the 10th, just to show you it's still up. And then we'll go to 2x to the 100. Right, and I'm going back to the graphing calculator just to show you those, and I'll go back to the chart. So if we take our x squared and we change it to a 10, you can see what happens to the graph. So it kind of like squares off at the bottom of the graph. When we do 2x to the 100, it will actually look like right angles. It is not a right angle. The reason being, there are a limited number of pixels on your graphing calculator screen. If we zoomed in, if we did 2x to the 100, like right in this tiny little narrow corner, you'd see a slight little curve on it, but we're not going to play around with that level. The concept I want you to get is it still curves, even though it's going to look square. Like this is approaching, looking like right angles. And then watch what happens if you go 2x to the 100. Just add 1 0 to the exponent there. It looks like a, right, fully square. Okay? It's still up, arrows on the end. It doesn't matter what the exponent is. If the exponent is even, it's going to be up. If a is negative, right, so if I just insert a negative, I keep getting the wrong thing, sorry. If I insert a negative, it just takes that thing and turns it upside down, right? So negative a, down, down, positive a, up, because it's an even exponent. So just as a general sense of how that chart works, if it's an odd exponent, and we'll just kind of talk generically about this, 2x cubed, right? Positive odd finishes up. That's how I remember that one. If you're a positive person, you're going to be up, emotionally up, right? If you're a negative person, you finish down, right? So that's how I remember that one, and I know if I finish down, I'm going to start up. So that's kind of the given in my brain. Again, create those little tricks for yourself. The little things I tell you may not work for you, but you can come up with your own, because eventually once you're in college, you'll have to come up with your own. And it's kind of cool once you do. Like when I remember historical dates when I was in college, my buddies and I were big, we were all on the football team. We loved Cleveland Browns football. We would use the Browns players' numbers to remember us, to help us remember historical dates. Like 1973 was Brian Sipe, Joe Deacon. And we'd remember the date because we tied it to something that we know and love. I did not like history. Social studies for you guys back in my day was called history. But little tricks like that will help you remember. One of the best tricks is a mnemonic. So if I want to remember what the 5 Great Lakes are, raise your hand if you can name the 5 Great Lakes. There should be nobody. If anybody can name them, I'll be stunned. So I learned this thing. I grew up in Cleveland, right next to Lake Erie. So it was a thing in 2nd grade geography. We had to remember the 5 Great Lakes. I still remember this. They gave us a little mnemonic called HOMES, H-O-M-E-S. So the 5 Great Lakes are Huron, Ontario, Michigan, Erie, and Superior. Okay, those are the 5 Great Lakes. I still remember that from when I was 7. That's 45 years ago. Right? So mnemonics are a powerful memory technique. Right? I feel like part of my job is to teach you guys how to learn. And if you use all these strategies I've given you to help you remember stuff, it just makes your life easier in the long run, so use them. Okay? That is the end. Let me stop my recording.